Hello, everyone. I'm Frank, and welcome to episode 46 of Learn How to Sudoku, where we take very easy variant Sudoku puzzles and we break them down in detail so that you can learn how to Sudoku. Today's puzzle is very easy puzzle is called Anti-Quads 2 by the Bard. And here are the rules. Normal Sudoku rules apply. Place the digits 1 to 9 in each row, column, and box. Quadruples. Digits in the white circle must appear in one of the four surrounding cells. So this quadruple cell rule has a 4 and a 9 in it. So the digits in that 4 are the digits 4 and 9, which are in that circle, must appear in one of the surrounding cells. So as an example, it could be a 4 here or a 9 here, or any combination, right? It just has to be in one of the four cells surrounding the quadruple rule. So, for example, if this says 1, 2, 3, 4, that means 1, 2, 3, and 4 have to be in all the cells, in each of the four cells surrounding this quadruple. And it can be in any order. It doesn't have to be one. It could be like 1, 4, 3, and 2 there. Or it could just be any order, right? But it has to have all the digits in that circle, in that quadruple clue, have to be in the four surrounding cells around that circle. And that's the quadruple rule set. We also have the anti-quadruple rule set, which is digits in the small pink. It kind of looks reddish to me, but maybe it's pink. Pink circle cannot appear in one of the four surrounding cells. So instead of saying being equivalent to the quadruple of saying there has to be the digits in the four surrounding cells, the anti-quadruple rule, which is specifically for the pink or red circles, have to say that the digits inside cannot be in any of the four digits that are surrounding that anti-quadruple cell. So this cannot contain a 1, a 2, a 3, or a 4 because those are specifically in the anti-quadruple rule. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. So let's learn how to Sudoku. Okay. So I like attacking specifically the quadruple rules that have 4 digits in them, because that simplifies things a lot usually. So this means these 4 digits have to be 1 through 4, right? These 4 digits have to be 1 through 4. These 4 digits have to be 1 through 4. Well, interestingly enough, since these 4 digits have to be the digits 1 through 4, that means the digits 1 through 4 cannot appear in the rest of the box. We also know this quadruple rule says that an 8 and a 9 have to appear in the 4 cells surrounding it. Well, these can't be 8 or 9, so where is the 8 and 9? It has to be here. So this is 8 and 9 here. And now we have an 8-9 pair and a 1, 2, 3, 4 quadruple in this box, which eliminates 1, 2, 3, 4 from the rest of the box, and 8 and 9 from the rest of the box. So these can only now be 5, 6, and 7. Well, interestingly enough, this quadruple rule says that you have to have a 1 and a 3 in the surrounding cells. But this anti-quadruple rule clue says that 1, 2, 3, and 4 cannot be in any of the 4 surrounding cells. So this has to be 5 through 9. And where are the 1 and the 3? They can only be in these 2 specific cells. So this can't be 2 or 4. This has to be 1 or 3. These both have, one of them is 1, the other one is 3 here. These, again, are all 5 through 9. Any of the 1, 2, 3, 4 anti-quadruples have to be 5 through 9. These two cannot contain 5 or 6 because of the 1, 5, 6 anti-quadruple. So this is specifically 7, 8, or 9. Eight cannot be any of these three cells because 8 has to be one of these cells. So this cannot, none of these could be 8. 3 has to be one of these two cells because it cannot be part of these cells. So this has to be, one of these has to be a 3. Um, we know in this box, 1 has to be in the surrounding cells of these 4 cells. So this cannot be 1, which means in these 4 cells, where is a 1? It has to be here. So therefore, this can no longer be 1, which makes that a 3. That 3 means this has to be a 1, because you have to have a 1 and a 3 surrounding this quadruple cell. So this can't be 1. These can no longer be 3, whereas the 3 around this quadruple cell, it has to be here. So this is 3, which means this can't be 3, which forces this to be a 3. So the 1 cannot be either of these, because this anti-quadruple rule says that this can't be a 1. So one of these two specifically has to be a 1. Similarly, 6 can't be here because of the anti-quadruple clue. So this has to be 6 also. So this specifically has to be 1 and 6. Well, this 1, 6, 1, 6 pair eliminates 1 and 6 from the rest of the row, so this can't be 6, but this quadruple clue still says that we need a 6 in the surrounding 4 cells. Since it can't be here, it must be one of these 2 cells, which means these can't be 6 here. So this is a 6, this is a 6. Where is the last 6 in row 7? It can't be any of these because of the 1, 6 pair. This has to be a 6, so that eliminates any 6 in this row. These can't be 6 because of the anti-quadruple clue here, so this must be a 6, which means these cannot be 6s either. One could be any of these cells. That's fine. 3 cannot be here. And 3 cannot be any of these surrounding cells, which means 3 has to be one of these 2 cells. We also know 3's here. 3 can't be here. 3 could be any of these cells. Oh, these has to be 5 through 9. Well, this can't be 6, 7, or 8 surrounding this anti-quad cell, so this must be 5 and 9. Well, this 5, 9 pair in this box eliminates 5 and 9 from the rest of the box, so this must be 6, 7, or 8. This 6, 7, or 8 eliminates 6, 7, or 8 in the rest of the row. So this can't be 7 or 8. This can't be 6, 7, or 8. We now have a 5, 9, 5, 9 pair in this box and in this row, in row 4. So that eliminates 5 and 9 from the rest of the box and also from the rest of the row. So this must be specifically 1, 4, and 2. 1, 2, and 4. Well, 4 has to be surrounding this quadruple clue, so this can't be 4. We also know 9 has to be in surrounding these cells, and so therefore, whereas the 9, it has to be one of these 2 cells because it can't be here. So since the 9 is here, this can't be 9, so this is 5, this is 9. Let's see, what else do we have? This can no longer be 9 because of the 5, 9 pair in the box. This can't be 9, whereas the 9, it has to be here. So this is a 9. Therefore, where is the 8 in this column, in column 3? It has to be one of these 2 cells. Well, that means neither of these can be 8, so this can't be 8, so that's a 7. This can't be 7 or 8, so this must be a 6. So one of these is an 8. The other remaining one has to be a 2 or 4. So this is 2, 4 with 8. This is 2, 4 with 1, and this can't be 1. So where's the 1 in this box? It has to be here. So this is a 1, which means none of these can be 1. Now we have a 2, 3, 4 triplet in row 6, which eliminates 2, 3, and 4 from the rest of the cells in the row. This can't be 2 or 4. This has to be an 8, which means this can't be 8. The 3 also has to be one of these two, because that's the only remaining. This has to be 5, 6, and 7. Therefore, this can't be 3. We now have a 1, 2, 4 triplet in row 5, which eliminates 1, 2, and 4 from the rest of the row. So this has to be specifically 3, 8, and 9. This can't be 9 again because of this quadruple clue. This can't be 3 because of this 3, and this can't be 3 because of this one of these has to be a 3. So this makes that an 8, which makes that a 9, which makes this a 3. Okay, where is the 9 in this box? Cannot be here. Can't be any of these because of the quadruple clue. Can't be here because of this 9, so it must be one of these two cells. And this can no longer be 9. This can no longer be 8. Where is the 9 in this box? Can't be any of these cells. Can't be any of these because of these two cells. It can't be here, so it has to be one of these two. This is 3. This obviously is 1. This can't be 8 anymore. Where is the 8 surrounding this quad? It has to be here. So this is an 8. Excuse me. These can't be 8, and these can't be 8. Hmm. Let's see. 7 has to appear around this quad clue. So this can never be 7. Therefore, we know specifically it's 5 and 9. So we have a 5-9 pair in column 7, which eliminates 5 and 9 from the rest of the column, which means this can't be 5 or 9, which gives us a 6-7 pair in this box, which means we can eliminate 6 and 7 from the rest of the cells in the box and the column. So this can't be 6 or 7. This is 5, 8, or 9 here. This is 6 or 7. So the rest of the digits in column 7 have to be 1 through 4. So this is 1 through 4. This cannot be 1, but it could be 2, 3, or 4. But this can't be 3 because of that 3. So one of these has to be a 3, so this can't be 3. This can't be 3. We now have a 1, 2, 4 triplet in column 7, which eliminates 1, 2, and 4 from the rest of the column. So therefore, this must be a 3. This can't be 3. This 1, 2, or 4, well, in this box, it says that there has to be a 1 or 4 around this quad. So this can no longer be 1 or 4, so that makes this is a 2, which makes that a 4, which makes that 1. This can't be 1. This is now 2 or 4. So this is a 2, which means this can't be 2. Whereas the 2 in this box, it has to be one of these two cells, which means this can't be 2. What else are we missing here? 1, 2, 3, 4. We have 5 and 9 here. This is 9 with something in else. We don't know. 4 has to be one of these two. 3 is there. 8 cannot be either of these cells because of the 8-9 pair in the row. So 8 has to be one of these two cells, which means this can't be 8. Where is the 8 now in this box? It can only be one of these two cells. 4 cannot be any of these cells because of the 2-4 pair here. And it can't be here because it has to surround the quad, so 4 has to be one of these two cells. This is 5 and 9. 6. 7 has to be surrounding it. 1 can be any of these 4. 3 can be any of these 4. 3 cannot be any of these cells, and it can't be any of these cells because of the anti-quad. Therefore, 3 has to be one of those two here. Which means these can't be 3, these can't be 3, so 3 has to be one of these two here. That doesn't tell us very much, unfortunately. Let's see. I think we've 5 cannot be here, and 5 cannot be here, and 5 can't be here. Where is it in this box? Then it has to be here. So this is a 5. This can no longer be 5. Okay, what are the remaining digits here? This cannot be 2. It could be 2, 3, 7, or 8. So this could be 3, 7, or 8, but this can't be 7. This can't be 2 because of the anti-quad rule. So the 2 has to be one of these two, and this can't be 2 because of the 2, 4 pair in the column. So therefore, this must be a 2. This then has to be 7 or 8. That's fine. This is 3, 7, or 8. 2 could be here. That doesn't help us much, unfortunately. 1, 5, and 6 are here. So 1 of 2 or 4 is here. And 1 of 7 or 8 is here. We're not sure which, though. None of these can be 5. This can't be 5. We now have a 6, 7, 9 triplet in column 4, which eliminates 6, 7, and 9 from the rest of the column. So this must be 1 through 4, but no 3, 2, and 3 are allowed, so this is 1 or 4. Since this is 1 or 4, only one of these two can be a 1 or 4. Therefore, the remaining digit, the remaining 1 or 4, has to be here, right? And we know the 1 or 4 has to surround one of these three, has to be in one of these 3 cells because of the quad rule. And it can't be both here, so one of the 1 or 4s has to be here, which means this can't be 8. This has to specifically be a 1 or 4. Well, where's the possibility for 8 now? It can only be here. So this is an 8, which forces this to be 7. So this can't be 7. We now know this is a 3-8 pair, which eliminates 3 and 8 from the rest of the box. Does that really tell us anything? Not particularly. So this is 1 or 4. Oh, this has to be a 3 because there's no other place for it now here. Can't be any of these. Can't be here anymore, so this must be a 3. The remaining digits here are 3, 6, 1, and 8. 1, 3, 6, and 8, but these can't be 3, and these can't be 6. This can't be 7 here. These can't be 7 here. Where's a 7? It has to be here. So this is 7. This is a 7, which makes that a 6. This can't be 6 anymore. So therefore, this has to be a 6 here. This can't be 8, so this also has to be 1 or 4. We have a 1, 4, 1, 4 pair now in column 9, which eliminates 1 and 4 from the rest of the column. Therefore, this is 8. This can't be 8. This has to be a 1 or 3. These can't be 8 here. This has to be a 5 or 9, but it can't be 9 because of the 8-9 pair in row 1. So therefore, this must be a 5, which makes this a 9. This can't be 9. Therefore, where's the 9 in column 4? It has to be here. So this is a 9. We have a 5, 6, 7 triplet in row 2, which eliminates 5, 6, and 7 from the rest of the row. This can't be 3, so therefore one of these two must be a 3. This is 1 through 4, but it cannot be 3, obviously. So this is 1, 2, or 4. We have a 6, 7, 6, 7 pair in row 3, which eliminates 6 and 7 from the rest of the row. Therefore, this is a 5. This can't be 5, 6, or 7, so this must be 8. This has to be a 2 or 4. Well, now we have a 1, 2, 4 triplet in column 6, which eliminates 1, 2, and 4 from the rest of the column. This has to be then a 6 because it can't be 1. This has to be 1. This can't be 1 here. These can't be 6. This has to be 5, 7, 8, or 9. Well, it can't be 5, 8, or 9 because of the 8, 9 pair and this 5. Therefore, this must be 6, 7. So this can't be 5 or 7. This has to be 6. This can't be 5 or 6. This must be 7, which means this can't be 7. So this is 6. This is 7. This can't be 7 or 6. So this is 5. This can't be 7. So this is 6, which makes that a 7. This 7 makes that a 5. This 5 and 7 makes that a 6. This can't be 8 anymore. This can't be 7, so this is 9, which makes that 8, which makes this 5, which makes that 9. Okay. Let's see, what else do we have here? So one of these is a 7. The remaining digits here have to be, cannot be 1 because one of these is a 1. Could be 2 here. Cannot be 3. Could be 4. Could be 5. No 6. Could be 7. But this can't be 7. This can't be 5. Okay. Do we have any information here? One of these is a 4. This is a 2. 2 or 4. 2, 4, 7. Ah, the 4 has to be surrounding this quad. I think I missed that earlier on. So this is 4, which makes this a 2, which makes this 1. This is a 4, which makes that 2, which makes that 4. This has to be 1, 4, 1, 4. This is all normal Sudoku. So we don't have a 4 here. Right, so I missed that 4 earlier. These can't be 4, so there has to be a 2, 3 pair. This can't be 4. Where's the 4 surrounding this quad? It has to be here. So this is a 4, which makes this a 2, which makes this 4, makes that 2. This is all normal Sudoku. This is a 4. This has to be a 7, because that's the only digit remaining. This can't be 7 or 4, so this is a 2, which makes that 3, which makes that 1, which makes that 3. Which makes, this can't be 2, so this is 3, which makes that 2. This can't be 4, so this is 5. That has to be 7. This has to be 2, and this has to be 1 by normal Sudoku. This 5 eliminates that 5, so this is a 9, which makes that 5. This 9 eliminates that 9, so that's an 8. This is a 9, and this can't be 3 here, so therefore that's an 8. And this is a 3 in the corner, and we solve it. And we celebrate. Yeah, sorry, apologies for not sort of clearing out or specifying how I'm approaching this. Sometimes it just basically flows really quickly. And I'm not really sure how to say, hey, I'm targeting this, right? Here we just had so many restrictions that it made it easy. And just anytime I saw essentially a triplet of cells containing only 3 digits or a pair of cells that contain only 2 digits, it made things much easy to to look for. Um, I would suggest that actually that's probably one of the primary ways that I solve a lot of Sudokus is finding pairs of cells which can only contain like two specific digits, right? Or knowing that you have to have a like for example a 1 or 2 in two specific set or two cells. That eliminates 1 and 2 obviously for the rest of the cells in the same row or the same column or the same box. Um, yeah, I mean, that's what I was using a lot here, particularly with the anti-quad rule set, right? Because that limits things also to what you can have. I think probably, yeah, focusing a little bit more on the quadruple rule set and what that eliminates too would also have been nice, right? So this would have been like, oh, I see a 1 and a 4 have to surround this quad cell, this clue. So this can't be 1 or 4, therefore it must be 2 and 3, right? That would have immediately been able to eliminate a lot of possibilities. Anyways, I hope you enjoyed this solve of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.